Hi everyone, I am Sailaja, working as Assistant Professor in the Department of Physics of Mlritm. In the last class, we have defined photoelectric effect, studied its characteristics, derived Einstein's photoelectric equation, and we have seen its applications. So what is photoelectric effect? When light of suitable frequency is incident on the surface of the metal, electrons are emitted from the surface of the metal. This phenomena is known as photoelectric effect. Next, we have seen when positive potential of plate C is increased, photoelectric current increases and it reaches maximum value. When negative potential of plate C is increased, we have seen that the photoelectric current decreases and it becomes zero at a particular voltage. So, the negative potential of plate C at which photoelectric current becomes zero is called stopping potential. Next, we have seen that stopping potential is independent of intensity and saturation current is directly proportional to intensity. Next, we have derived Einstein's photoelectric equation, that is h nu is equal to W naught plus half mv maximum square. W naught is known as work function. Work function means the energy required by the electron to come out of the metal surface is known as work function. And we have also derived another form of Einstein's photoelectric equation, that is V naught is equal to h nu naught minus h nu naught V naught is equal to, we have also derived another equation of Einstein's photoelectric equation, that is V naught is equal to h by E into nu minus h nu naught by E. So, this equation shows that the graph between stopping potential and frequency is a straight line of slope h by E and y-intercept minus h nu naught by E. So, from this equation, nu naught is, we can define nu naught. What is nu naught? Nu naught is threshold frequency. Threshold frequency means it is a minimum frequency which causes photoelectric effect. So, if the frequency of incident radiation is greater than threshold frequency, photoelectric effect occurs. And if frequency of incident radiation is less than threshold frequency, photoelectric effect does not occurs. We have also seen that this photoelectric effect is used in burglar alarms and in automatic door opening systems. Okay, so today I am going to explain about wave particle duality and de Broglie hypothesis. Wave particle duality. So before going to understand what is wave particle duality, first let us define what is a particle and a wave. So what is a particle? Particle means a particle is one which has mass and it is located at some definite position in space. So particle is specified by mass, velocity, momentum and energy. Next, what is a wave? Wave is spread out of disturbance. It is spread out of disturbance in medium or space. Wave is specified by frequency, wavelength, amplitude, frequency, wavelength, amplitude, phase and intensity. Next we will try to understand what is wave particle duality. Radiation has wave particle duality. Radiation behaves as wave in some experiments. Radiation behaves as wave in some experiments like interference and diffraction. Why? Because these experiments require presence of two waves at the same position and at the same time. At the same position and at the same time, this experiment requires two waves. Since two particles cannot occupy the same position at the same time, therefore in these experiments, radiation behaves as wave. That is, in experiments, interference and diffraction, radiation is behaving like a wave. Next, in some experiments, radiation behaves as a particle. In some experiments like photoelectric effect and Compton effect. Photoelectric effect and Compton effect. Because according to quantum theory, radiation interacts with matter in form of photons. Therefore, we can conclude that in these experiments, that is photoelectric effect and Compton effect, radiation behaves as particle. So this dual nature of light, from these 2 points, we can conclude that radiation is having dual nature. That is, in some experiments it is having wave nature, and in some experiments it has particle nature. This dual nature of light is known as wave particle duality. You can see here, wave particle duality. Radiation has dual nature. That is, in some experiments like interference and diffraction, it behaves as wave, while in some experiments like photoelectric effect and Compton effect, it is behaving as particles. This dual nature of radiation is known as wave particle duality. So radiation cannot exhibit these 2 phenomena, that is particle nature as well as wave nature, simultaneously. Radiation cannot exhibit these 2 phenomena simultaneously. See, that is, in this figure, we can see that in interference pattern, the radiation is having wave nature. We can see here, radiation is having wave nature. In interference pattern, wave nature, radiation is having wave nature. Why? Because this experiment requires the presence of 2 waves at the same position at the same time. For example, if you take any point here, this point, here we can see 2 points are existing at the same position as well as at the same time. Therefore, we can say that in interference phenomena, radiation is having wave nature. Radiation is having wave nature. Whereas in photoelectric effect, radiation is having particle nature. Why? Because in photoelectric effect, we know that radiation is interacting with matter. So according to Planck's theory, we know that whenever radiation interacts with matter, it has particle nature. Therefore, we can say that in photoelectric effect, radiation is having particle nature. Radiation is having particle nature. So what is wave particle duality? Wave particle duality means what? That is, dual nature of radiation is known as wave particle duality. Next, let us understand what is Debroglie hypothesis. So Debroglie made 2 hypotheses. They are, the universe consists of matter and radiation only, and second one is nature loves symmetry. So in this figure, you can see that universe is consisting of matter as well as radiation. That is, everything that is present on the surface of the earth is considered as matter, and the earth is receiving its energy or radiation from sun. Therefore, from this we can say that universe is made up of radiation as well as matter. Second one, nature loves symmetry. Symmetry means fundamental entities should have similar characteristics or properties. So what are the fundamental entities present in nature? The fundamental entities present in nature are radiation and matter. The fundamental entities present in nature are what? Radiation and matter. That means here both radiation and matter should have similar characteristics. Therefore, from this we can say that since radiation is having dual nature, matter should also have dual nature. So, basing on these 2 hypotheses, Debroglie in 1924 suggested that just like radiation, matter also has dual nature. Matter means material particles like electrons, protons also has dual nature. That means they have both particle nature as well as wave nature. Now, according to Debroglie hypothesis, a moving particle is associated with a wave. That means as long as the particle is at rest, if the particle is at rest, it has particle nature. If this particle is moving with some velocity, then waves are associated with it. That means it has wave nature. Whenever the particle is at rest, it is having particle nature, and if the particle is moving with some velocity, then waves will be associated with it. That means it has wave nature. So now what is Debroglie hypothesis? Debroglie hypothesis means dual nature of matter is known as Debroglie hypothesis. And that means whenever the particle is at rest, it is having particle nature. Whenever it is moving with some velocity, it has wave nature. So now let us try to define what is matter waves and Debroglie waves. So the waves associated with material particles are known as matter waves or Debroglie waves. So this is a diagram which is representing the matter wave. So you can see here, this is a particle. So whenever the particle is at rest, it has particle nature. That means no waves will be present associated with it. Whenever this particle is moving with some velocity, waves are associated with it. So this wave pattern is showing, this wave pattern is known as matter waves or de Broglie waves. Whenever the particle is moving with some velocity, waves are associated with it, and those waves are known as matter waves or de Broglie waves. So this is a figure showing you the matter waves or de Broglie waves. And the wavelength of these matter waves is given by lambda. Lambda is equal to h by mv, or it is equal to h by p, where m is the mass of the particle, v is the velocity, and p is its momentum. Now let us derive an expression for de Broglie wavelength. So to derive an expression, we know that according to Planck's theory of radiation, energy of photon is given by E is equal to h nu. Nu means here frequency. So E is equal to h nu by lambda. We know that nu is equal to c by lambda. So in the place of nu, you can substitute c by lambda. So now E will be equal to hc by lambda. Next, according to Einstein's mass energy relation, we know that E is equal to mc square. Since equation 1 and 2, they both are representing energy, we can equate them. That is mc square is equal to hc by lambda. So we want expression for lambda. So lambda will be equal to hc by mc square. So here c will get cancelled. What is the value of lambda now? Lambda will be equal to h by mc. So this lambda is equal to h by mc is representing the wavelength of radiation. Why? Because here c is representing the velocity of light. But we want expression for wavelength of a matter wave. So for a material particle moving with velocity v, now the particle velocity is v. So in the place of c, now we have to replace it v. So lambda is equal to h by m into v. We know that mv is nothing but momentum of the particle. So lambda will be equal to h by p. So lambda is equal to h by mv, which is equal to h by p, will give you the wavelength of de Broglie waves or matter waves. Next, de Broglie wavelength in terms of kinetic energy. Now we will derive an expression for de Broglie wavelength in terms of kinetic energy. So let us assume that E is the kinetic energy of the particle. So what is the formula for kinetic energy? Kinetic energy is given by half mv square. So now we are multiplying and dividing this equation by m. Then we will get it as half m square v square by m. So we know that mv is equal to momentum p. M square v square will be p square. So this equation becomes p square by 2m. P square by 2m. E is equal to p square by 2m. So what is the value of p square from this equation? P square will become 2me. So from this now p will be equal to under root of 2me. So what is the wavelength of matter waves? It is given by lambda is equal to h by p. So now in the place of p, we can substitute under root 2me. So lambda value will become lambda is equal to h by under root 2me. So this equation represents the wavelength of matter waves in terms of kinetic energy. Next, de Broglie wavelength associated with electrons. So let us consider the case of an electron. Now we have taken an electron. The mass of the electron is m and its charge is represented by E. So now to this electron, we are applying some voltage or potential. Then what happens? The electron gets accelerated. That means it is moving with some velocity. So now we know that the kinetic energy of the electron will be equal to the potential which we have applied. So half mv square, kinetic energy is half mv square is equal to potential difference is charge multiplied by voltage E into V. So from this, what will be the value of V square? V square is equal to 2eV by m. This V is representing voltage and this V is the velocity of electron. So from this, V value will be equal to under root of 2eV by m. So we know the value of lambda again. What is the value of lambda? Lambda is equal to h by m into V. In the place of V, we will substitute under root of 2e by m. So h by m into the place of V, we should substitute 2eV by m. Now when you take m into inside the root, it will become h by under root of 2e capital V m square by m. So here m will get cancelled. So what will be the value of lambda here? Lambda is equal to h by under root of 2m e into v. What is h here? Planck's constant. M is mass of the electron, E is the charge of the electron, and V represents the voltage which we have applied. So now we will try to substitute the values of all these and see what is the value of H. Planck's constant value is 6.625 into 10 to the power of minus 34 joule second, and M is the mass of the electron. Mass of the electron is 9.1 into 10 to the power of minus 31 kgs, and E is the charge of the electron. Charge of the electron is 1.632 into 10 to the power of minus 19 coulombs. So after substituting all this, V is remaining like that only. So when apart from V, all these things if you are calculating, you will get the value is how much? 12.26 value. Lambda is equal to 12.26 by, this is remaining here, so root V angstroms. What is the value of lambda now? Lambda is equal to 12.26 by root V into root V angstroms. Okay, so whenever if you having an electron which is accelerated, that means if an electron is moving with some velocity by applying some potential, then if you want to calculate its wavelength, we will use this formula. That is 12.26 by root V angstroms will give you the wavelength of electron which is accelerated with potential V. Now next we will see what is Debroglie hypothesis. Characteristics of matter waves. In Debroglie hypothesis, we will see what are the characteristics of matter waves. So we know this equation, lambda is equal to h by mv. Now let us see the characteristics of matter waves. So we know this equation, lambda is equal to h by m into v. So from this equation, we can see that lambda is inversely proportional to mass and velocity. That is, if mass or velocity is more, the mass or velocity of the particle is more, then wavelength will be less. So now what is the first characteristics? You see, lighter the particle, greater is the wavelength associated with it. Lighter the particle means if mass of the particle is less, then its wavelength will be more. Wavelength associated with the particle will be more. So let us try to understand this with an example. For example, you consider two particles. One is football and other one is electron. We are taking two particles here. One is football, other one is electron. And these two particles, they are moving with the same speed. That is, I assume 10 meters per second. These two particles, they are moving with same speed, but their masses are different. Here, mass of football is greater when compared to mass of the electron. Okay, so from this equation, we can see here if mass is more, that means mass is inversely proportional to wavelength. So since the mass of football is more here, what is happening? Its wavelength will be less. Wavelength is less. And electrons' wavelength will be more. That means more waves are associated with electrons when compared to football. That means here electron is having wave nature when compared to football. Waves will be associated with football, but the waves will be very small, that cannot be predicted. Why? Because here its mass is more, wavelength will be less. So that the waves cannot be predicted in the case of football. Therefore, it is not having wave nature. Electron will have wave nature. Next characteristics is lesser the velocity of the particle, longer the wavelength associated with it. That means if the velocity of the particle is less, then wavelength associated with it will be more. For example, you consider here two electrons, they are moving with different speeds. So their masses will be same, but they are moving with different velocities. For example, this first electron velocity is more when compared to the second electron velocity. Velocity of second electron is less. So if velocity is more, what is the value of wavelength? Wavelength will be less. And here, since velocity is less, wavelength will be more. So from this, what we can see here, that means slow moving electrons will have wave nature. Why? Because its wavelength is more. Slow moving electron will have wave nature, whereas fast moving electron will have particle nature. Next, for V is equal to 0, lambda is equal to infinity. In this equation, in the place of V, if you substitute 0, what will be the value of lambda? Infinity. Or we can say V is equal to 0 means the particle is at rest. Whenever the particle is at rest, no waves will be associated with it. That means matter waves are associated only with moving particles. So this means that only with moving particles, matter waves are associated. Next, electromagnetic waves are produced only by charged particles. But whereas matter waves can be produced either by charged particles or uncharged particles. So therefore, matter waves are new kind of waves. They are not electromagnetic waves. You can see here whether the particle is charged or not, matter wave is associated with it. This reveals that these waves are not electromagnetic waves but a new kind of waves. So next characteristic is matter waves travel faster than light. Matter waves travel faster than light. Let us prove this with an equation. So here E is equal to h nu represents what? It is the equation of energy of photon, and E is equal to mc square, that is from mass energy relation. So since these both are representing energy, we can equate them. So h nu is equal to mc square. Here h nu is equal to mc square, and wave velocity omega is equal to nu lambda. This nu is what? Frequency. Omega is equal to nu lambda. So now what is the value of nu from this equation? We will get nu is equal to mc square by h. So in the place of nu, now we can substitute what? Mc square by h. Therefore omega is equal to mc square by h into lambda. What is the value of lambda? Lambda is equal to h by p, or it is h by mv. So in the place of lambda, we will substitute now h by mv. Omega is equal to mc square by h into h by mv. So here h gets cancelled and m get cancelled. Then omega will be equal to c square by v. What is v here? V is representing the velocity of the particle. C is the velocity of light. So we know that velocity of the particle cannot be greater than velocity of light. So for example, you take the velocity of light value is 3 and particle velocity is 2. If you substitute these values in this equation, what you will get? Omega is equal to 9 by 2, which is nothing but it is 2.5. So what is the value? It is 4.5. You will get here 4.5. So omega value is how much? 4.5, and velocity of light is 3. So that means here omega is greater than c. So this equation, from this equation we can say that matter waves travel faster when compared to the velocity of light. So as a particle velocity, we cannot exceed velocity of light. C, omega is greater than velocity of light. So just now we have seen here since v cannot be greater than c, so from that equation what we got now? Omega is greater than c. So the same point we are saying here, as particle velocity cannot exceed velocity of light, omega is greater than velocity of light. So no single phenomena exhibits both particle nature and wave nature simultaneously. So no phenomena at the same time cannot exhibit wave nature as well as particle nature. That means if in one experiment it is having wave nature and in some experiments it has particle nature, it cannot exhibit two phenomena simultaneously. So the wave nature of matter introduces uncertainty in the location of the position of the particle. Heisenberg's uncertainty principle is based on this concept. So whenever, as long as a particle is at rest, it is having particle nature. But whenever this particle is moving with some velocity, what is happening here? Waves are created among this particle like this. So now, since the wave nature of matter here has created uncertainty in the position of in locating the position of the particle. That means the particle can be anywhere within this wave packet. Here the particle can be anywhere within the wave. So we cannot find the exact position of the particle. So from this, uncertainty means we cannot locate exact position of the particle inside the wave. So this dual nature of matter or wave nature of matter created uncertainty in the position of the particle. And this has led to a new principle known as Heisenberg's uncertainty principle. So this principle we'll see in the next class. So we have seen today what wave particle duality and de Broglie hypothesis. Wave particle duality means what? Radiation has dual nature. So this dual nature of radiation is known as wave particle duality. And what is de Broglie hypothesis? Matter has dual nature. So it is matter is having dual nature. That means in some experiments it has wave nature, and in some experiments it is having particle nature. So dual nature of matter is known as de Broglie hypothesis, and we have also seen the characteristics of de Broglie hypothesis. So references: Engineering Physics by Dr. S.L. Gupta and Sanjeev Gupta, Engineering Physics by P.K. Pallanaswamy. Thank you.